Hey, welcome. So today we're going to take this incredible journey to figure out what makes our home, planet Earth, just so special. We're zooming all the way out to the cosmic scale and then right back down to the ground beneath our feet, all to answer one massive question.
And this is really the big one, isn't it? I mean, we live in a universe that has, well, probably billions of planets. So why is this the only one we know for sure is just bursting with life? What is Earth's secret? Let's get into it.
Okay, so to really start this quest, we need to first wrap our heads around just how fragile this world of ours is. It's something that's really easy to forget in our day-to-day lives.
Now just think about that for a second. That quote is so powerful. If you could hold the entire Earth in your hand, like an apple, everything, every mountain, every ocean, every single living thing, would be on a layer no thicker than that shiny skin. It really puts into perspective how precious and delicate our little corner of the universe is.
And you can see it here. Below that incredibly thin skin, that crust, you've got thousands of kilometers of mantle and core. But all the action, all of life as we know it, it's all happening right up here on the surface. That's what makes it so mind-blowingly special and so fragile.
All right, let's zoom out. To really get why our home is so unique, we need a little bit of context. So let's take a quick road trip through our cosmic neighborhood, the solar system.
So just looking at this, you'd probably expect a simple pattern, right? The closer a planet is to the sun, the hotter it's going to be. And yeah, for the most part, that kind of holds up. Mercury's hot, Earth is nice and comfy, and Neptune, way out there, is basically a giant ice cube. But wait a second, do you see the puzzle here? And here's that puzzle, you just can't miss it. Take a look at Venus. It's actually farther from the sun than Mercury is, but wow, it is scorching hot. We're talking more than double the temperature. So clearly, just being close to the sun isn't the whole story. Something else is going on.
And this is the question that really cracks open one of the biggest secrets to why Earth can support life. The answer has less to do with distance and everything to do with what a planet is wearing. Its atmosphere.
So yeah, the answer to our Venus puzzle is a little thing that's absolutely vital for understanding our own planet's climate. It's called the greenhouse effect.
So what is it exactly? Well, to put it simply, it's a warming process. The easiest way to think about it is like a blanket for a planet. Some planets don't have a blanket at all, some have a nice, cozy one, and some have a blanket that's way too thick.
It's actually a pretty simple three-step dance. Okay, so first, sunlight comes in and warms up the ground. Easy enough. Then, the ground radiates that heat back out toward space. But, and this is the all-important part, certain gases in the atmosphere grab some of that escaping heat and bounce it back down, keeping the planet warm.
And this is what makes Venus and Earth totally different worlds. Look at this. Venus's atmosphere is almost pure carbon dioxide, which is a super powerful greenhouse gas. It creates this runaway effect that traps a crazy amount of heat. Earth, on the other hand, has just a tiny fraction of that, just enough to keep our temperatures stable and, perfect for life.
Okay, so we've got a fragile crust and this perfectly balanced atmosphere. But what even allows that balance to exist? That brings us to what might just be the single most important piece of the puzzle.
I mean, really? What allows Earth to have this perfect atmospheric blanket? Why aren't we a frozen wasteland or a burning hot desert? Well, it all comes down to that old real estate saying, location, location, location.
See, if Earth were just a little bit closer to the sun, our oceans would literally boil away. All of that precious water would just poof, turn into steam, and life as we know it, impossible. And if we were farther out, well, even with our nice atmosphere, the planet would get way too cold. All of our water would be locked up solid as ice, just a frozen, barren rock. But our orbit, our little spot in the solar system, it's just right. It's the absolute perfect distance to allow for the one thing that is essential for pretty much all life to evolve and survive.
And this sweet spot has a famous name, the Goldilocks zone. It's this exact positioning that lets water on Earth stay mostly in its liquid form. And that, my friends, is the true secret ingredient. Liquid water. It's the universal solvent. It's the medium where all the amazing chemistry of life can happen.
So, let's put all the pieces back together. What have we actually learned on our little tour? What's the secret recipe that makes our planet a living, breathing world?
Well, here it is. It's not any one single thing, but this beautiful, delicate combination. You need a solid surface to live on, that thin, fragile crust. You need that perfectly tuned atmosphere to keep things warm, but not too warm. And all of that is only possible because of our perfect location, which gives us the ultimate prize, oceans of liquid water.
And this really is the key takeaway. It's not one thing. Earth's magic comes from this incredibly delicate combo of factors all working together. If you change any one of those ingredients, our orbit, our atmosphere, our water, this vibrant, amazing world could become just as lifeless as any other rock floating out there in space.
And that kind of leaves us with one last big thought. We figured out that this Goldilocks zone is absolutely key. But is that it? Is just being the right distance from the sun the only thing that matters? Or are there other things going on? You know, subtle factors like our planet's size or its magnetic field or the fact we have a giant moon. That's a question to chew on. And it just reminds us that the more we learn about our amazing home, the more we realize how much is left to discover. Thanks for joining me for this explainer.